Hello, what I'm going to do today is talk a little bit about circumpolar constellations. Hopefully this will go fairly quickly. I'm actually going to be borrowing a shockwave file from the Astronomy Education Department at the University of Nebraska, Lincoln. They actually have quite a few of interactive applets, as you can see here. I'll be demoing some of these, not all of these, because some of these are actually dealing only with the upper level astronomy class, and I'm going to be dealing with just a high school astronomy section. So what I want to do is to talk about circumpolar constellations. If you take a look at it, we actually look toward the center here. In fact, actually I can make this a little larger. This is taken, I'm not exactly sure where. We have some lights, people walking around down here. We have a tree that doesn't move, mountains that don't move, and we have a sky that looks like it does. If you look at some of these star trails, like that one right there, you can actually see that it's not halfway around, it's not a quarter of the way around, it's maybe a 20th, a fifth of 20% around, a fifth of the way around. And they all should be just about, actually maybe they're not even that. So, but if you take a look at it, we probably have 4 hours of motion here. What basically happens, this is the east side, this is the west side. Stars rise in the east, and I've already covered this section with a celestial sphere. So they rise up this direction, they move across the meridian, which is the point between the south, which is behind you. We're looking to the north right now. And goes through Polaris, or the North Celestial Pole, which is right there. That is Polaris, and you can see Polaris does have some motion, so it's not exactly at the center. But then it goes over to your zenith, which is the point directly above your head, and goes to the south, which is behind you. So we have, this is the meridian. Things rise on this side, the right side of the meridian, and they set on this side, the left side of the meridian. But you see some of these stars actually don't set at all, and this is what sets up a circumpolar constellation. Okay, back to the Astro section at University of Nebraska Lincoln. This is animation you can see, and this is going to be talking about the revolving sky explorer. And what we're going to do here is we're going to take the Earth view and the horizon view, and you can do a couple things on here. You can actually shut off a whole lot of things, and including making this a sky dome rather than the whole celestial sphere. And I may actually try to do this, because if you try to show the whole thing, some of these stars get confusing on whether you're watching them go on this disk, or if you're watching them go on that disk, this disk, which would actually make this sort of semi-transparent. So I'm going to keep this as a sky dome. And what you can do is you can actually throw on some sky patterns. There's the Big Dipper. I'm going to throw on Orion, and I'm even going to throw on one Southern Cross, although we won't get to see this one because it's going to be taking this orbit right here. We can throw on random stars. Actually, let me go ahead and just start playing this. Let me actually remove all the stars. Let me just start playing this. And you notice on this one, you can't see anything moving except for the Earth. Now it starts out at around 41 degrees north latitude, 96.7 west, which puts it in Nebraska. I'm going to slide it just for my general case to 38.8 and 77, 78.9. Okay, that's right around Northern Virginia, and you can see that we're located right here now, right there, and this is the orbit that we take. You notice that's not quite as big as if we were at the equator, and we can spin this. You can't really see anything moving because everything is shut off, so I'm going to show the celestial equator. If you were standing on the equator and you drew a laser and burned in dots and connected them with a line, this is the line that would be moving. I'm going to show the 0 hour line, that's the meridian line, so we actually have a declination line, 0 declination, that's the 0 0, oh, I hate that when that happens, declination and amplitude, not amplitude, azimuth. So this is the azimuth reading of 0 degrees, and it also is 24 degrees, and things actually move in hour increments, so seconds also. I can throw on random stars, and I'm going to pause this. I'm going to throw the Big Dipper, I'm going to throw Orion, I'm going to throw Southern Cross. Notice that Orion's belt, the 3 stars, and you have to imagine this thing is on the far side right now, so we're seeing it the way it would normally look from an Earth observer, except that we can't see it here in Northern Hemisphere because we're in the summer. So what we have to do is we have to wait for this thing to orbit around. It doesn't show day and night, so it actually is in our daytime sky. But the belt of Orion is really close to the celestial equator, so anytime you can see this up in the sky, and let me start it, and see it's not moving over there because it's the Earth, and eventually we'll see it come up here in the east, and I'm going to let it stop right about there, and we're seeing it backward now. There's Betelgeuse, there's Rigel, there's the belt of Orion. That top star of the 3 belts, that one's almost right on the celestial equator. So everything you can see above that is in the north celestial hemisphere, and everything you see below that, including a whole bunch of sky here for Northern Virginia, this is in the south celestial hemisphere. Okay, so let's go start the animation. Let me throw in some random stars. You can see some are actually in the southern. Let me go ahead and throw that. There's the celestial sphere. And this is where I said it gets kind of confusing, is what stars are you seeing where. But I'm just going to put some random stars up there. You can see they're all rising in the east, they're all setting in the west, exactly like what this thing is showing. Rising in the east, setting in the west. If you go back to the animation, if I throw on the circumpolar region, this is the section of the sky that, for an observer where we are in Northern Virginia, never seems to rise and set. The stars still come up in the east, they still try to set in the west, but the horizon's not big enough. That also bodes for the section of stars that we never see. Anything that happens in this circle, we will never see. And where is that Southern Cross? Here it comes, and notice for Virginia, you can never see. You move down to Florida, you can see this, but if you're here in Virginia, you never get to see the Southern Cross. So these are stars that you never get to see. And then if I show these, this is called the rise and set region. I call these the equatorial stars, but these are stars that rise and set. They rise in the east, they move across the meridian, the south to zenith, to Polaris, to north. They cross that meridian. If we're talking about the sun, anything that's before that is the anti-meridia, which is AM, and post-meridia, which is PM. You can throw labels. So there's the celestial equator. Here comes the 0 hour line. You can also show the angle between, and for us it's like almost 51 degrees between the celestial equator and our latitude. And what you do is you figure out 38.8, you add that to that, and you get the 90 degrees that's going to go. If we went down to the equator, which is right about there, you notice that they're all rise and set stars. If you go up to the North Pole, notice they're all circumpolar stars. If you go to the South Pole, stars you never got to see, where's the Northern Cross? Southern Cross, sorry. There it is. It is a circumpolar star. So if you're at the poles, they're all circumpolar. If you're at the equator, they're all equatorial stars. They all rise and set. And if you're anywhere in between, you get little sections of both. All right, thank you much. Appreciate it. Bye.